Hello learners, I am Dr. Ashish Das, Assistant Professor in Economics at OSOU. Today we shall discuss about game theory in this video lecture. So basically, game theory is the study of the rational behavior of the interdependent agents. Agents have a common interest to make their pie as large as possible. At the same time, agents have competing interest to maximize their own pie or own share of the pie. An agent's rational decision requires anticipating rivals' responses. These expectations are not perfect, so uncertainty is necessarily an integrated part or feature of games. Now we shall discuss about some related concepts. So economic situations are treated as games. A game is the collection of rules, regulations and conventions known to the planners and observed by the player. You know, any game, for example cricket, we have an umpire who regulates the entire game. So there are certain set of rules, who can bowl how many balls in an over, or how they can bat, or who should bat first. So there are rules for the game. Similarly, in the game of economics also there are set of rules, conventions that are observed by the players, and there is an umpire, maybe the regulator, who regulates the game. So it is a situation in which two or more participants, that is the players, confront one another in pursuit of certain conflicting objectives. Rules of the game state who can do what and when they can do so. Strategy in the game is a part or is a plan of actions of a player in each possible situations in the game. Payoffs are basically the amount that the player wins or loses in a particular situations in a game. Payoff matrix basically shows all possible outcomes in a game. So, if we try to classify or we classify the games, it is possible to classify in terms of the number of players, that is 2 persons game or 3 persons game or n person game. Similarly, it is also possible to classify the game in terms of the strategy, that is finite strategy or infinite strategy. Similarly, it is possible for us to classify game in terms of payoff situations, such as constant sum game or non-constant sum game. We can also classify games in terms of pre-play negotiations. For example, we can classify a game as a cooperative game or non-cooperative game. Now, maximum and minimax strategy. So, if strategy of player B are 4 and there are 3 strategy available to player A, and the payoff matrix is as shown in the table, you should take the maximum value of each row. Like here in the first row, that is strategies of player A, we have 50, 90, 18 and 20. So minimum in the row is 18. Similarly, if you go for strategy 2, we can see 27, 5, 9 and 95, and the minimum among these is 5. Strategy 3 for player A has a payoff of 64, 30, 12 and 20. So among these 4 payoff, 12 is the minimum. So we got the row minimum, and we can take the maximum of the minimum, that is 18 here. Similarly, now we can come to the column maximum. In the first column, that is strategy B strategy, we can see 64 is the maximum. In column 2, we can see 90 is the maximum. In column 3, we can see 18 is the maximum. And in column 4, we can see 95 is the maximum. So, among these maximum, the minimum is 18. So, we can easily see that the maximum of the minimum is equal to minimum among the maximum, that is 18. So, 18 is the saddle point solution here. So that means the player B should adopt strategy 3 and player A should adopt strategy 1, so that the final payoff is going to be 18 in this case. Now we shall discuss about a very vital concept, that is prisoner's dilemma. Prisoner's dilemma basically describes a situation where in the absence of complete information, individual rationality leads to group suboptimality. Now, if you look at the real life situations in oligopoly market structure, advertising industry basically use the prisoner's dilemma or falls into prisoner's dilemma most often. Now, we can explain this prisoner's dilemma through a simple example. Suppose there are two persons to whom the police authority suspects that they are involved in a particular crime. Okay. Now, what happens? The police authority do not have a complete proof of their being involved in the crime. So they need additional evidence. Now they design a game. The game is they basically hold or they catch hold of these two suspects and then put them into two different rooms. Then they define the rules. As we told, there are certain rules in the game. The rules of the games were formed and this has to be observed by the player, and the players are also aware of what is the outcome if they do or adopt a particular strategy. Now, the police authority told that suppose you confess and your counterpart or your friends is also confessing, then both of you will get 2 years of imprisonment. Suppose you are not confessing, your friend will be let free and you will get a punishment of 10 years of imprisonment. Now coming to the first column and second row, suppose you are not confessing and your friend is confessing, then the person who is not confessing will be freed and will be get 10 years of imprisonment, and because the person who is confessing is supporting the police authority will be let free. Now both of you are not confessing, then the payoff is 0-0 because the guilt cannot be or the crime cannot be proved. Now, in these situations, most likely what will happen is that suspects are kept in two different rooms, so they cannot talk to each other. Their decisions are interdependent. However, they cannot communicate among each other. Now, this lack of communication will put them into a different sort of thinking. Now, they would like to minimize their punishment. So, they would be always skeptical about their friends with whom they cannot communicate now, that if he adopts the strategy 1, that is confess, okay, and you are not confessing, you would end up with 10 years of imprisonment, which you would like to avoid. So in such situations, the suspect will also tend to confess. So both the suspect in this case will confess and get 2 years of imprisonment. So here what is happening, though the global optimal is 0-0, both of them could have adopted a strategy of not confessing if information flow would have been allowed. Now, in the absence of such information flow, they are basically confessing that they have done the crime and getting 2 years of imprisonment. So, in the absence of complete information, here incomplete information is what the opponent will strategy would be. The opponent would be taking what strategy is not known to them. So, in this context, in the absence of complete information, they end up with a suboptimal outcome rather than an optimal outcome. This is all for today, and we shall come out with more videos covering more such concepts in forthcoming sessions. Thank you.